All right, so I'm going to go over page 321, or the homework at least for this section. So here we go. So if you're watching this, way to go. So page 321, question 1. All right, so we're asked to make a 4-digit passcode. So that's definitely like we'll be able to use our fundamental counting principle. And there's a credit card arriving in the mail. Determine the probability that the passcode will consist of 4 different even digits. So you have to read that carefully. The passcode will consist of 4 different even digits. So that's basically saying the different part says no repetition. Can't use the same one twice, and they have to be even. So let's see how we tackle this one. Remember, probability is n of that restriction that we were given over the universal. Let's do the universal first. It's probably easier. 1, 2, 3, 4. You've got, because it's digits, we're assuming it's 0 to 9, so it's 10 to the power of 4. For NA, the only numbers that are even would be 0, 2, 4, 6, and 8, right? So we've got 1, 2, 3, 4, 5 digits, and then 4, and then 3, and then 2. It's not 5 factorial because we don't have 5 slots to fill in, but it's 5 pick 4 in a sense, right? 5 pick 4. And so if you calculate that, you can either do it here. So that would be 5 pick 4 is basically 5 factorial in this case because the 1 gets cut out. So that's 120 over 1 followed by 4 zeros, right? And so that's your answer. If you divided that, you get 0.012. So there we go. That was your first question. Question number 2. In a card game called Crazy Eights, I'm going to put that over here. Crazy Eights, players are dealt 8 cards from a standard deck of 52 playing cards. Determine the probability that a hand will consist of 8 hearts. Okay, so let's see here. Our hand has 8 cards, 52 possible, and you're wanting the probability that all 8 are hearts, so 0 of any other kind. Okay, so again, it's hands of cards. This would be combinations for sure. And so our probability, again, n of A over n of universal. Let's do the universal first. Out of my 52 cards, I would choose any 8 cards. Right, so that's 52, choose 8. That is a big number. Maybe I'll write it down later when I come up with my fraction. And then NA, here you have to be careful. You want 8 hearts, so out of 13 hearts, that's a whole suit, right? You want to choose 8. And you can, this is optional, but you know it's going to be 1 in this case. But I still think that you should always think of it just in case it's not. 39, choose 0. From the other that are non-hearts, we're going to choose none of them. That's just 1, right? So that is our probability here. So I'm going to write down, I already calculated this. This is 752, 538, 150. And the top is 1287, right? And so this is your probability. If you divide that, let me just do that here for you. That's a very small decimal. It's 1, 2, 3, 4, 5 zeros, and then 171. Okay, so you can always check the key is way back. Key is on, I think, page 615. That's what I have written down. 615 at the back of the booklet. Put a sticky note there. Question 3. From a committee of 12 people, I'm not even gonna, right? It's most likely gonna be combinations, right? But a committee of 12 people, 2 of these people are randomly chosen to be president and secretary. Determine the probability that Ben and Jen will be chosen. Okay, so this one is a little tricky, I have to say that. Because you see committee of 12 people, you're thinking combinations, right? Keep reading. 2 of these people are randomly chosen to be president and secretary. Their president and secretary talks about specific positions that need to be filled. So determine the probability that Ben and Jen will be chosen. Okay. So the fact that from the 12 you're filling in these 2 positions, it tells me that this is permutations. The committee has already been formed that has 12 people. So from those 2 you want to pick from those 12, right? So don't let that fool you. Okay, so question 3. Sorry, I had to stop for a bit. So basically, the probability again, NA over NU. Okay, what's NA? Well, there are 2 positions to be filled: president, vice president. But well, how about we do the universal first? President, vice president. You can pick 12 from the committee. 12 can be the president, and then once you've chosen your president, you have 11 left for your vice president. Versus this is you want those 2 individuals, right? Ben and Jen. So you've got Ben and Jen to choose from the first option, and then you've got 1 left for the second. Okay. So your probability ends up being 2 over what's 11? 132, or 12 pick 2. And you can reduce that, of course, and that would be 0.015, or you can continue if you want 4 decimals, right? But anyways, that's your answer there. So question 4. I'm not sure if I'm going to be able to finish this. Might have to do it in 2 parts. My lunch is almost over. But let's see here. 5 boys and 6 girls have signed up for a trip. Okay, only 4 will be selected to go on the trip. Determine the probability for the following. Only boys will be on the trip. I don't know if you see that, but only 4 students will be selected to go on the trip. It's a combination scenario, right? You're picking any 4. Order doesn't matter, right? If 4 students are selected, if that's just one group, we don't count it again if, for example, those 4 were called in a different order. I don't know if you see that, but anyways, this is combinations here. So you want only boys on the trip. I think you would be able to get that part. I'm just gonna set up my question here. I know that I have 5 boys and 6 girls. 6 girls. Gotta make sure I get that right. So 11 total. It's a good observation. So for A, for the probability, there's NA over NU. Okay, so the NA part, or the NU part, would just be from the 11, I would choose 4. That's it. For NA, you want only boys, so 5, choose 4, right? All 4 will be, and then technically from the 6, choose 0, which is just 1. Okay, so here we have our, I will just quickly do that on the side here. 11 choose 4 is 330. 5 choose 4 is just 5 times 1. So that's 5 over 330. So that would be, you can reduce that, of course, 0.015. if you went one more decimal, that'd be 2. Okay. B, what is B asking? There will be an equal number of boys and girls on the trip. So for probability, I already know that my NU is 11 choose 4. That's already been determined. That's not going to change. It's the top that's going to change. So let's see here. So that means if you want both of them to be the same amount from the 5, you would, 5 choose 2 times 6 choose 2. Right? You choose 2 from each group. And so this would be 10 times 15 over 330. So that is 150 over 330. And cancel that. That's 15 over 33. 3 goes into both of them. 5 over 11, right? And then you reduce that, you divide that. That'd be 0.455. There we go. So for C, what's it? There will be more girls than boys on this trip. Oh boy, more girls than boys. What does that mean, right? Like, I'm just wondering if you see what I see there. More girls. So that means that if a group has 4, then you want to consider 3 girls and 4 girls, right? In both of these instances, you have more girls. Or, so you have to consider both. The instance where there would be 3 girls and the instance when there are 4 girls. Let me just move this up a little bit here. Running out of room. So for probability, the bottom doesn't change. The denominator does not change here. But 3 girls, that means that from the 5 boys, you would choose 1. And from the 6 girls, you would choose 3. You have to extend this. Or from the 5 boys, you choose none of them. Because when you have 4 girls, then your committee is full. Okay, so if you add this, you have your 4, and here you have your 11. So it's either this or that. Okay, so 5 choose 1 is just 5. 6 choose 3 would be 20. Plus 5 choose 0 is just 1. And 6 choose 4 is 15 over 330. This would be 100 plus 15, that's 115 over 330. Sorry about the bell there. 115. This would be C. And there it is, 0.348. You can tell that 5 goes into both of them, so you can reduce that. So that concludes 4. I'm gonna stop here, and if time allows, I'll do another one where I continue with the homework, but just keep going and look at your answers and see if you need to change anything. It's a learning curve, all right? Good luck with the rest.